Hello, everybody. This is October 29th, and this is the OLM Feature Planning meeting. On today's agenda, Evan Cordell is going to discuss some operator scoping. He's going to discuss scoping in OLM. Evan, do you want to take it?
Yeah, sure. I will share my screen. If I can find the right one to share. I think this will be right. Oh, hold on. I have not granted Zoom permission. 1 second. Apologize. I'll have to rejoin.
Okay.
All right, let me try this again. All right, is this visible?
I can see scoping cluster extensions.
Yep. Perfect.
Yep.
Okay, so this is, looking at the scoping cluster extensions. This is basically when you install an operator or a controller into a Kubernetes cluster or an OpenShift cluster. How do we deal with the scope of those things? So to set some context, right, the default controllers in Kubernetes don't really have a notion of scope, right? They watch all namespaces. Pods are available in all namespaces. Deployments are available in all namespaces, or they're not namespaced objects at all. They're cluster scoped resources. And then I can control access to that via RBAC. But with custom extensions to a cluster via whether that's an operator framework operator or just a pod running a controller, those pods running within the system can also be scoped down. So you can configure an operator or a controller to only watch one namespaces. You can configure it to watch 10 namespaces, though it's not very efficient because it has to open one connection per namespace, or you can configure it to watch all namespaces. And so OLM, well, I'm getting ahead of myself. Let me look at sort of what we're considering to be the user stories around scoping. So the first one is like, why do people care about scoping at all? And one is that you, as an administrator, you expect to be able to install operators that don't watch the entire cluster. So we can maybe talk about whether that's a reasonable expectation, but this is definitely what people coming to operators coming to Kubernetes are expecting to be able to do with controllers that they write and install on a cluster.
Yeah, just to expand on that. So the customers that we're dealing with are expecting namespaces to be a tenant, right? So they're expecting that not to have any cluster role bindings at all, right? They're expecting just role bindings and to have that there. And so that's kind of where we're kind of tackling this problem from our end too in the meantime. So I totally agree with this.
Yeah, okay, well, we'll do a +1. For all of these, it'd be really interesting to get feedback on whether this jives with everyone else's experiences as well. So the next one is the ability to run multiple instances of a single operator. So this is one where, as a cluster administrator, you want to be able to deploy more than one for a few reasons. One is that you might want different operators with different level of permission. So you might want one for like a prod environment and one for a dev environment, but the same exact operator. You might have multiple tenants. So like Chris, like you were saying, if your users are expecting to treat namespaces as tenants, they might want to install operator per namespace to reduce any sort of noisy neighbor effect, even though you can still have those for other reasons because it's a shared cluster. Or install different versions of an operator because they support different operand versions. And operators don't have to be written such that the operand is tied to the operator version, but it is a fairly common pattern people use, especially when we talk about air-gapped clusters. That's really common for those scenarios because it makes it easy to identify all of the sets of images that actually need to be mirrored into an air-gapped environment, which is not easy to do if you don't know what operands will be running ahead of time. And then the final one is
plus one for
yeah.
me on that. All those. That's great.
All those? Okay.
Yep. Yep.
Glad to hear that this is resonating. So the next one is, as a cluster administrator, I want to be able to install operators that have conflicting dependencies, whether that's via APIs or other operators. And so this is basically if I have two operators that share transitive dependency, I still want to be able to install those two operators even if they require different versions of that transitive dependency. So that this is somewhat more deeper into like the OLM realm of things that users need to care about. But users do get frustrated if they install an operator, it installs a transitive dependency, and then they try and install something else and they can't install it because the transitive dependency that's shared between them can't support both of the top level operators that are attempting to be installed. So this is a pretty common frustration that people have. So this is probably not totally comprehensive everything everyone might care about scoping, but this is trying to distill it down into a few high level goals and user stories.
Yeah, I think another one that would be bolt on that is a user experience that makes it obvious, right? What mode you're running in and what that is, right? So how do you make that transparent for like debug purposes and all that kind of stuff, right? So don't hide it deep down inside the SAT solver or something like that. Let's make it part of a little bit more in your face of what's going on so you can actually see what's happening, because ends up being complicated. But maybe that's a side effect, but.
I think I agree with the story. We should probably write that. I took a note to add that in later. Yeah, understanding the current state is a problem. I have another example somewhere that I might get to for that. Anyway, I'm going to quickly go over how OLM deals with these problems today. I think this audience is probably relatively familiar with them, so I won't spend too much time. But most of this is implemented via operator groups today, which is a resource that OLM manages that defines where and whether an operator deployment can be created. So you can only create an operator if there's an operator group, and when you do, it defines where it can be installed. It also defines what namespaces the operator is given permission to watch, and also what namespaces the operator is available to be used in, and what permissions the operator can be given. So operator groups can be associated with a service account, and you can only install operators that have less than or equal to the permission of that service account. OLM deals with some scoping issues by asking operators to declare which APIs they own and in which namespaces they own them. And then we say that no two operators are allowed to own the same API in the same namespace, which is not strictly necessary, but it prevents more problems than solutions that it prevents.
Is it in the same namespace or the same operator group?
So no two operators are allowed to own the same API in the same namespace. So if you have two operator groups, they can potentially have overlapping target namespaces, but OLM ensures that.
But you can have an operator group that has an overlapping API?
You can have two operator groups that overlap in namespaces, but you can't have two operators own the same APIs in the overlapping namespaces.
Okay, got it.
Because 9 times out of 10, that's not what users were trying to do.
Right.
So some of the sharp edges with this today. So installation and resolution happens within a namespace and within a single operator group. And this has a bunch of unfortunate UX effects, which is that if you have an operator that depends on another operator, it has to be able to run at the same scope. So since operator groups define the set of namespaces, all dependencies need to be able to watch that same set of namespaces or the installation can succeed. And this also has some unfortunate effects with transitive dependencies where if two operators share a dependency and those two operators are going to be installed in different scopes, so imagine two separate single namespace operators and they want to share an operator, because they need to share it, that dependency needs to be installed as a something that can be available in both of those namespaces, which means it has to be installed sort of ahead of time, which means you don't get any benefit from dependency resolution because dependency resolution happens at the scope of the operator group. This is a sharp edge for Kubernetes in general, I would say, but when you've installed an operator and an API, whether it's a CRD or an API service, the APIs are visible in discovery, but they're not necessarily active globally. So this is, again, getting back to how APIs work with standard kube. You see the API, if you have permission to use it, you can use it, and then the controller reacts to it. But that's not true with custom controllers because custom controllers may not have permission to watch the entire cluster. So just because you can see the API in discovery doesn't mean that you can use the API in a given namespace or that it will even react to anything that you do in that namespace. And technically, this is not like really a guarantee that Kubernetes gives you, right? Like there's no official contract that writing a deployment in namespace, if I have permission, the deployment controller will do anything. But that's definitely the implicit contract with those APIs. So it also doesn't allow shared ownership of APIs with this model because we don't allow two operators to own the same API in the same namespace. That means I can't do things like the ingress APIs where I have one single API and multiple other implementations, and then they just are trusted to be good citizens and trusted that they'll only interact with the ingress objects that have their blessed annotation on them, even though there's nothing in our back that can actually enforce that. So I'm going to walk through like a few different broadish categories of solutions we've looked at to solve these problems, just to sort of overview of some of the discussion, I guess. So one option is to essentially delegate all of this to the operators themselves. And I'm using this to say that OLM doesn't care about the scope of the operator. OLM just says, this thing declares it owns the API. We're allowed to have one owner of an API in a cluster, so I'll just install it. And what that means is that if you need additional scoping or you want to run multiple controllers for different tenants or anything like that, you can do all of that, but it has to all be coordinated through this single entry point that is the top level operator that got installed. This makes it sort of act more like Kubernetes APIs, but I think it's worth saying that like OLM is not going to verify that it's doing any of that. They'll just install it and say, it is installed and it says it owns this API, so we're done. So that removes a lot of the dependency resolution sharp edges because one thing owns the API for the cluster. So if something declares a dependency on an API, we'll go find the thing and install it. But we still have a bunch of other problems. You can't reason about the availability of the dependency because there's no implicit or explicit contract that just because the controller is running, it's reacting to anything in your namespace. We still can't install multiple instances this way. This model relies on global singleton control over an API. And we can't install conflicting dependencies this way. So we can't have two top level operators that depend on different versions of their transitive dependency.
So have you guys given any thought to kind of providing a layer on top of the API that would allow you to, for example, artificially inject the namespace into the API group of the API and make the API kind of dynamic? So I've been toying with that idea of like, what if OLM actually was able to templatize the CRDs and the code to be able to basically do a pseudo namespace scope to a CRD. That way you don't have that potential problem. You could have another kind of abstraction above that, so you don't have that ownership problem.
So that is a solution we've talked about before. It also has a bunch of sharp edges. So in order to do that, right, like you said, the operator needs to know to be configurable to watch different APIs.
Right.
And that also can be tricky with dependencies as well. If you install an operator that has a dependency, does that operator need to be configurable to watch not just its own APIs, but does all APIs that the operator watch now need to be injectable and configurable? And then now we have a sort of a delineation between operators that have been built from community or other sources versus operators that have been built specifically to run within OLM. And that has been a thing historically we've attempted to avoid, right? Any controller pod you write with anything should be a thing that OLM can install for you.
Okay.
I think you could even go further along that route and say, even if we went and abstracted away access for operators to the API, let's say there was a pod that we injected into the deployments of the things that we installed to the cluster that basically intercepted API requests and made sure it routed it to the correct thing based on which namespace you're in. You still end up having sharp edges from the kubectl perspective and externally, because those things don't look like they do to the operator itself.
Yeah, we've definitely shim layers like that come up a lot as potential solutions, but it always feels like we're fighting the system rather than working with the system.
That's fine. This is an idea I've had for like a couple months now. I just hadn't fully iterated on it because I don't appreciate the depth of the problem, and I'm glad you guys have thought about it. So
yeah, it's probably, we should just keep like a log of all these things, because some stuff, like that we talk about maybe doesn't make sense at the time, and then maybe a few months down the road you revisit it and some things have changed and makes a little more sense now. So it'd be good to sort of try and track some more of that. I only have a few more. Another like small variation on this is saying, okay, all operators are global, which when I say this, to try and be really specific, I say that like global meaning the operator works like the deployment controller, because I think there's different ways you can interpret global, but it works like the deployment controller. API is available everywhere. You control access via RBAC. So in this model, only one operator can declare ownership of an API in a cluster. And they can either be global, sorry, I should say they are global unless they explicitly say, I cannot be installed as a dependency of anything. And what that does is it changes this a little bit, right? So we still have the same problem of can't install multiple instances and can't install conflicting dependencies, but now it does remove the dependency resolution scoping problems, because now I know if I have a dependency, it has to be installed at the cluster scope and available for all namespaces. So all dependencies, now I can reason about what availability they have. So that's slight variation to remove one of the edges. And then another one is just the straight up all operators must be like the deployment controller. It's not actually a thing we could enforce. We can't know what the pod will do when we start it, but it's something that we could say, like, if you're shipping an operator in OLM, it should work this way. And if it doesn't work this way, that you know, we have this expectation, so users should like essentially go to the operators and say, why don't you work this way if you're shipping an OLM, rather than how does OLM support not working that way? If that makes sense. So this has some nice features, right? There's no scoping problems at all. Everything is available in the cluster. And there's no question about where APIs are actually available. But it does mean that we still can install conflicting dependencies. So this is kind of where I'm starting to step back out and say, so what this means is that if we have this model, then the way you deal with conflicts is you have multiple clusters. So we're kind of getting into like the crux of the problem, which is like multi-tenancy or multi-cluster. And so going this route solves a lot of these UX problems, but it does cost more, right? You have to run more clusters to get this done.
Yeah, so this is, yeah, so that is basically using the singleton concept, right? Where you're not, there is no, so I'm a little confused. So this solution basically disables all the namespace stuff, right? So this is basically all of the requirements you had in the beginning, this negates, right? From multi-tenancy in a cluster. Am I missing something?
Nope, you're not.
Okay, all right.
So yeah, so that's the part. So like here's these sharp edges, right, for OLM, and it's like, how do we remove these sharp edges? Well,
right.
every step we take towards removing the sharp edges negates some of these user stories at the front. And so, so that's why we're in. That's kind of like why this is a hard problem.
I just wanted to make sure that I wasn't missing something, because this totally is not a solution.
Yeah, maybe that's the option, I guess. I don't know, potential future, right? So yeah, that's kind of where I was getting with all of this. Like we can't provide the experience that users are asking for within a single cluster. We don't have the primitives to do it in Kubernetes, or at least that's my feeling. And we can provide it if you look up a layer and you say, well, I'm actually operating a set of clusters as tenants rather than a set of namespaces as tenants, or a set of sets of namespaces as tenants. Then actually all of those user stories work fine. Like I can tweak those user stories a bit and say, well, now my scope is actually just within the same, instead of cluster, call it set of clusters. And now all the user stories are possible. And we've also removed the sharp edges. But this isn't like really an answer. Oh, I don't know if this is useful, but I'll try it out. This is my analogy. Like this is, if you're using Yum and you're trying to install something on a computer, and you do like Yum install something, and then it asks you a ton of questions, and for each RPM that it installed to install your top level package, it asked you what subset of users on the system it should be installed for. And if it's already installed in the system, it needs to ask you, oh, do you want to keep it installed for the same set of users, or do you want to change the set of users it's installed for? But then also every RPM is actually like a kernel extension. And so you can't install it just for some set of users without affecting everyone. Like that's kind of the scenario we're talking about for this tenancy problem, the scoping problem. Like we're fundamentally dealing with some cluster scoped abstractions and trying to shove them into boxes with shim layers and things like that. And I think that's why the sharp edges exist. That's all the slides I have. This is one of those like, and now I don't have an answer, right? And I think it's pretty clear that we have two general paths to take. One is try and push forward on abstractions in Kubernetes that would provide the building blocks to actually build this within a single cluster, or go the route and say that if you have any of these other problems, you just install a new cluster. You spin up a new cluster for it. And then some of the, like this, just going based on some of the things that I've spoken to with other groups, like I've talked to the API server and auth folks a bit in Kubernetes, and and describe some of these problems. And their opinion was largely like, I was pitching basically we need primitives in Kubernetes, like Troot and things like that let us build containers in Linux. We need similar primitives in Kubernetes. And I kind of got the feedback that maybe we do, but it's like on a 10-year timescale of happening. That was kind of the impression I got. And so for OLM and for operator framework, does that mean that we should be focusing on the thing that gives us the reasonable user experience, if expensive, by focusing on multiple clusters, and then use all of this experience to help feed into the 10-year tendency problem for Kubernetes? That's kind of where I'm leaning right now, but I'd be interested to hear other feedback and opinions.
Yeah, so that's unfortunate because there's so our customers are being sold on the fact that Kubernetes clusters can be multi-tenant. And in fact, there's a whole program that is basically selling Kubernetes as in that thought. And so customers are trying to build 1,000 node clusters with that whole idea of segmenting departments, applications, and so forth with that. And so if we want to elevate devolve operators to be cluster scoped things, then maybe we need to create another spec that's, maybe we didn't call them operators anymore, we call them something else. And that kind of dives into what James was kind of talking about. He created RFE about decoupling the API from the operator. It gives us a little bit more granularity, but maybe it's a more advanced use case.
It does, yeah. I'm definitely sympathetic to all of that, and I wouldn't characterize my opinion as set in stone or anything like that. But even some of those solutions, right? Installing an API object and then having multiple controllers that can watch separate spots, it actually still has all these sharp edges of users have to understand, when I install a thing, what scope is it watching? And if I want to make automated installation or modification to that set, it becomes untenable pretty quickly if I have 3 namespaces with some operators in them, depending on another namespace that serves all of them, and I want to install a new thing. Again, it's like this analogy that's on the screen, right? It's like, for every installation that I want to do, I kind of need to understand the entire state of the cluster and every set of namespaces that every controller is watching, and then make decisions about those and mutate them the way that I'm trying to get to, which is a lot of state for people to understand. I'm not saying it can't be done. I'm just, I'm not sure that it's a thing that can easily be automated, right? Because it requires human decision for most of the steps.
I think we need to draw pictures around that problem. And I think we need to try to simplify it, because there's always going to be sharp edges without the platform being able to support some of that. And I think it's our job to try to soften those edges as much as we can, but still realizing that there are definitely use cases that customers are demanding to do that. And I think there's a lot of opportunity here for that, to make that better. So this, I appreciate what you talked about here, and this is kind of, kind of throwing in the towel, I guess, to some degree, which I'm not saying is bad. It's good for that one user experience, but this other side of which, that's where all the customers want to go, at least our customers, right? And there's a lot of opportunity there to make their lives easier.
I totally agree. And oh, sorry, Nick.
I was just going to ask, like, the customers that you're talking about, is it a requirement for them that they install different, like, kernel extensions, or essentially different kernel extensions, different cluster extensions, depending on which scope they're in?
It's not. So really, it's about, so we sold operators, right, as a way, not to extend the cluster, a way to manage your applications. The fact that it's a cluster extension is a side effect. right? So the customers don't
Yeah.
see it that way, right? They see it as a way to manage and install application life cycles, right? So how can we abstract the fact that it's an cluster extension from that domain?
So I think that's where the culprit is, right? Because in this case, the customers have been lied to.
Yes.
This is
Exactly.
this is not something that manages your application. This is something that makes the cluster manage your application. That is a key difference. So the cluster is extended. It's not some sort of client Go based implementation that just sits there with its own API and its own UI and its own UX and does things and is completely outside of the Kubernetes realm. So operators were always about making Kube do things and tricks that it couldn't do before, or requires Kube in action and Kube extension. So if we sold them that operators are application managers that are running on Kube but are otherwise completely isolated, then that is our fault and we need to walk that back because that's not the reality. We make Kube behave differently because we slot something in the middle when requests are processed. Because
Yeah,
they go
so I think the problem is that because namespace scope and own namespace is a primary use case.
But it's a use case for the application use in the user space. It's not a use case for something in the control plane. So the example that Evan has here is very fitting in my eyes because we now have the same problem that containers were solving on the operating system, right? So we had all these application issues with their dependencies and package managers that made it hard to install more than one application on an operating system. So first we came up with virtualization, that was a lot of overhead. And now we came up with containers, which is much less overhead, but ultimately has the same goal, isolate that. Well, unfortunately, containers are still sharing the kernel. And so do we in Kubernetes. We still share the same control plane. That doesn't make it any less multi-tenant capable. It's just that this multi-tenancy was focused on the user space. And this isn't user space, this is control plane, kernel space. So I think we need to kind of get on the same page that we explain this correctly to the customers. Yes, for applications, Kubernetes is multi-tenant capable fully, right? It's well isolated and even more isolated on OpenShift with SE Linux and all this stuff. For extensions, for add-ons to the cluster itself, which is what operators are, this is not multi-tenant capable. An add-on that I install to my product will always influence all the tenants of that product. That is universal truth in the entire industry. Product extensions are global, have always been global. So I think it was not correct to teach customers, Kube is multi-tenant capable, you can do whatever you want in your namespace.
So I think the mistake is that people are bundling operators and operands in the same sentence. So I think maybe we need to make the operand lifecycle more friendly, right? So the operator ends up becoming what you said, it's an extension to the control plane, but it actually doesn't do as much, right? It's the operand that is the real lifeblood of what makes it interesting for multi-tenancy for customers. So how do we elevate that?
I think this is a separate problem space, not any more, not any less important and impactful. But I think I don't want to make the problem we are talking about any more complex, nor do I want to just drift away from it because it is still kind of a problem, right? And no matter how we kind of use or model application lifecycle on Kubernetes, we still want to have scoping and dependencies between the operators as well, because the reuse and the flexibility you have with this is still important, right? Even if the customers are really only caring about the application.
No,
So
I get that.
That notion, and I think we should definitely make that like a top-level initiative of this project to start caring about more of the application lifecycle. Getting closer to the actual consumer of the service on the cluster. and make that a first-class citizen as well. But I want to just stick for 1 minute longer to this particular issue. So I think Evan has done a phenomenal job in explaining what is currently possible and what is the demand, and kind of coming to the conclusion that, you know, not everything is possible. We cannot meet all the demands right now. But maybe there is like a middle ground that we can meet on and still provide a value proposition of OLM when it comes to managing multiple operators in a cluster, right? So one thing I've been wondering in this presentation is that we keep the dependency resolution as something that happens on cluster and that happens at runtime and is governed by OLM. What if we remove this aspect and we make the dependency a concept of the packaging, so that you as an operator author can still draw from a pool of existing operator projects, but rather to expect them to be installed by OLM, you ship them in your own catalog as part of a collection of operators that you need, including your own operator. So that would basically mean that every operator can now come from its own catalog and can bring its own dependencies. And maybe we find a way and some reasonable rules to make these dependencies all be installed with that operator that requires them in one namespace. And that is configured to watch a subset of the rest of the namespaces on the cluster, which is obviously still enforcing the overlapping rules and stuff like that. So we would essentially still not support running multiple wildly different versions of an operator claiming same API ownership. They all need to own the same API and the same definition. Only then they are regarded, we can assume they are compatible, or can reasonably assume they are compatible. And then that would most likely mean it's always going to be the same operator version, right? But effectively, we would allow separate instances of the operator, and we would also allow separate instances of the dependencies. So we move away from shared dependencies on the cluster, but we move towards dependency sharing that happens in, you know, operator registries, right, that are out there, where you can just pull the bundle and make it part of your catalog. That is what you test. This is what you support. This is what eventually gets installed as part of a collection that your operator product is basically comprised of.
So that's interesting. That's kind of like a statically linked operator, right?
Sort of, yeah.
Doesn't use any shared libraries and install. I mean, it still has a lot of these problems, right? Where, okay, they all come together as a pre-configured set. But if I install two different pre-configured sets that potentially conflict, I have a problem, right? I still can't solve that.
Mm-hmm. Right. They conflict when they introduce APIs of the same group version kind, but different or different versions and different schema, right? So I think today we have a lot of problems already in the initial stages where actually there isn't an incompatibility really. It's just an incompatibility from a version level, but really that the operators would work, you know, alongside each other just fine, because eventually the API didn't change and the behavior didn't change. It's just that the version changed because some bug was fixed or whatever. So I'm not talking about enabling use cases where you have operator A and B that have vastly different implementations of the same API, and then they are somewhat expected to work side by side in the same cluster, right? So I think separating the API compatibility problem from the somewhat helps us move forward, right? So the problems exist when these two operators try to work on the same thing, which we kind of do not allow as part of our operator group concept today, right? We make sure that there's no overlay overlap in watch and ownership of a certain API in the same namespace from two different operators, even if they are the same version. Doesn't matter. They're not able to do that. So that's how these operators would never reconcile the same object. And now the problem that remains is that the definition of the object schema is global, and as long as the schema used by the version of the schema is used as the same, even they're completely different, that shouldn't be a problem anymore, right? As long as we guarantee they're not trying to reconcile the same thing at the same time, then that collision is out of the way, right?
I think if I'm following, I think to a degree that removes some of the problem. But I think I don't know if you're around for the last community call that we did, but James brought up this idea of splitting out the API definition and the conversion webhook into a separate package, which I think addresses a similar problem in that you basically factor out the ownership of the API into its own package, and then you install other controllers that just share that definition. But I think the important part there is that the conversion webhook is also included. So that thing is updated independently from any controllers that require those APIs to be used. But again, I think that solves some problems, but I don't think that really solves the sharp edges here. Like all these problems around scoping, I think you still have to worry about those. Like you have to worry about the same controller watching the same API in the same namespace. You have to worry about understanding what's available in different namespaces and that kind of thing.
So that's kind of where I would potentially make up some constraints that users of OLM just have to live with if they want to continue to enjoy that feature of being installed multiple times. So when we talk about interaction between dependent and dependency, it would always need to happen in the same namespaces that they watch with each other. It cannot happen so that the set of namespaces needs to intersect 100%, right? So the interaction pattern is defined as if operator A requires operator B, it would only ever need to watch the same namespaces that both are watching. Sorry, that came out all garbled. What I'm saying is, most of the time this works today, right? That there's no problem. So because the point of interaction is in the same namespace where the CR is. So let's say I have an operator A that depends on operator B, and the user uses operator A to do something and creates an object in the namespace. That usually entails operator A talking to operator B using its API in the same namespace, right? So if we enforce that as the communication pattern between dependencies, that you can only ever consume your dependency in where you are reconciling your custom resources, that will kind of shrink the problem space significantly, right? Because then you don't need to worry about different watch configs, and they're going to be the same anyway because the operator A and B are installed always together, always in the same namespace, and are always watching the same namespaces defined by the shared operator group. So we don't have shared dependencies anymore at all on the cluster.
So it's a little weird because it sounds very similar to what actually happens today, and I think I'm missing how this solves some of the problem. Like for example, let's say I have an operator group that defines all namespaces, and I install an API like Elasticsearch there, and then I make another operator group that only watches 4 namespaces, and I install an operator set, pre-resolved set, and one of them requires Elasticsearch.
Yeah, it wouldn't get installed.
It would just fail to install.
Yeah,
okay.
So that would be a conflict, right? That's not something how this would work. So I'm thinking of the Elasticsearch problem as well. So in this new world, you cannot have an operator installed globally and then as well as consumed in a smaller scope. That wouldn't work anymore. So what customers would do is, this is where cluster logging and service mesh have the shared dependency of Elasticsearch, right? So what happens in this world is that there is an operator collection called service mesh, and it contains Chiali, Jaeger, and Elasticsearch. And it comes with a certain, when it's installed, it watches a set of namespaces. So it can either watch all namespaces or just 10 of the cluster. So that would mean we would install this thing. We would basically install all 6 or 7 operators that belong to this collection, among them service mesh. And they would all watch that 10 namespaces that the user is supposed to, or the tenants are supposed to use this, this service. Then someone installs cluster logging, right? And cluster logging comes in a separate collection that also contains Elasticsearch, right? And it does that by actually shipping the bundle as part of that collection. So when the admin installs this collection, that again installs the Elasticsearch operator along with cluster logging and all its other dependencies in a separate namespace. And they are watching a separate set of namespaces, which is what, where cluster logging should be available. So the only constraint we need to make here is that either we enforce that both Elasticsearch versions need to ship the exact same GVK, and there cannot be any difference, right? Either they all support V1, V2, V3 at the same time, or they all support V1. There's no mix and match and something that requires conversion. It always needs to be the same set. Wouldn't that alleviate these concerns that we have today?
If I understand what you're saying, I think it does remove some of the problems, and then I think there's a new set of problems of, hey, I can only install one Elasticsearch. Like, it doesn't solve the problem of like I need 2 different versions of Elasticsearch operator because they each only support one real version of Elasticsearch. Because that's how the operator was written, right?
You can install different versions as long as they all use the same API schema, right? We don't care about what they do in their watch namespaces as a result of getting an API request via that common schema, but as long as the schema is the same, that is the same data structure exists in etcd as part of a request, it's fine, right?
Aren't you watering down the API then? The API will end up having nothing but optional parameters, and it's gonna be really hard to use. Because how do you leverage, what's different about the versions if just the controller's different, unless the API actually evolves, right?
Well, we have learned that actually there's a lot higher velocity on the controller side than on the API side, because of all kind of bug fixes. So that's why we moved away from API-based dependencies in the first place, because the APIs would always stay the same, but they would always require certain controller versions to be available because they contain bug fixes or change some other interaction with kube in the backend that is never reflected in the API. So it seemed that APIs evolve much more slowly than the operators themselves. And hence we moved away from API-based dependencies because there was no way to enforce a certain operator version where the fix of a certain issue is in. So
no, I get that, but there is a lot of people who love rich APIs, right? So they like creating CRDs that have lots of parameters in them, and that's a problem because those are very fragile, and because you have just a huge surface of things that need to be modified. But that's where I think that's where the confusion is, because everybody thinks that, oh, the kube API is just like a REST API. I'll just use it like that, and I'll just keep, I'll have version 47 of that thing, and then not understanding that is really, really hard to migrate, especially in a controller world or in an operator world. So then your API ends up becoming super basic. All it ends up doing is basically an operand lifecycle, a really easy one.
yeah, I'm not saying that this edge goes away, but it might be worth investigating if that is a lower price to pay than than disallowing the operator to be present more than once at all. So how many people do we impact with that limitation versus the more drastic limitation of you will never be able to install operators that share the same API or the same operator twice, but with different dependencies and consumers. So I think it might be worth asking or investigating what the impact of that is. Because, you know, in that world, we kind of keep some of the promises and features that OLM was set out to do, right? Make all this seem somewhat easy and, you know, somewhat safe, as long as you do it through OLM as a system. You can definitely have multiple controllers reconciling the same API on Kubernetes. There are just a couple of rules and precautions you need to adhere to, and that might be something that is hard to enforce across projects without either the developers being the same or a central middleman like OLM that does that for you. Like it looks at the API and sees, this is not compatible, this is a different version. You wouldn't be able to store, to make this work with two different operators or different operator versions. Right? So the question is this more useful than having a system that doesn't allow the operator to be installed more than once in the first place? Because there are still all these other requirements, like I want separate instances, I don't want the control paths to be shared among tenants, I don't want, I want to be independent of other operators using my dependencies in the system and all this stuff, right? It doesn't completely get us out of the woods, but it would be some sort of a middle ground that isn't as drastic as saying we forget about operator tendency and installing an operator more than once. We just manage visibility and access to its APIs, but it's always there. It's always that single version, and it's always global. We could that too, right? That's kind of
I think we're
suggested, right?
I think we're like at the end of the time for this meeting. I really did want to bring it back to Chris in terms of what the end environment, the production environment looks like for your customers. But maybe we could talk about that next time. Like I want to know what it looks like to deploy an end environment for a tenant in production. Like, so is it just that I'm like applying a bunch of manifests for CRs, or am I applying, am I like managing a deployment? Like I kind of need to know how that works for different tenants.
Yeah, so I think the problem is the catalog. So I think the problem is Operator Hub, right? So the thing where it's a Red Hat thing, right? So we're trying to leverage that as a discovery and install mechanism for applications, not just the operators. And so I think that is a mistake, and it needs to be, we need to be installing a super operator that manages other operators as if they were operands, right? Because I think that whole concept needs to be decoupled rather than smushed together, because I think there's a fundamental misunderstanding that operators are replacing Helm, right? and so I think that's kind of where people are kind of going for it. So they think, oh, this is just a Helm catalog, I'll install this, and then so this must be multi-tenant, must be all this other stuff, and it's not. So I think we need to kind of rethink that whole thought. And this is something I've understood, but it's really hard to get everybody on the same page. And I think there's some problems on both ends here with messaging and not understanding that.
To kind of look for what you would envision then is that installing an operator is not installing an operand for your tenant. It's basically making the ability to install an operand available.
Right.
And now my question is that ability to install an operand, is it important that that is sliced up by tenant in terms of different versions
yes.
of that operator that's installing those operands, or is it just different versions of the operand itself?
Yeah, so for my company, our primary business is to sell software, right? So we are selling software, and we're using OLM as a vehicle to manage the lifecycle of that software. So it's all about the operand. So, and our customers want to be able to run multiple versions of that software simultaneously on giant clusters. And they want to be able to segment everything independently. So the operator, having the operator and the operands glued together is a mistake in that, because that completely destroys that capability. So they need to be way more decoupled than they are now.
So, but let me riddle this. So if an operator supports a range of operands to deploy, and you have a cluster that has an operator that makes this CR that supports a wide range of versions that you may want to use of the operand that you're installing, and manages the upgrade between those as well, would that solve the issue for a majority of your customers across tenants that you've defined at the application scope?
I think so. And I think we're doing that in some degree. So James is on here, Aiden is on here. So they're actually owners of one of these very large interconnected applications called Cloud Pak for Integration. And so they could, I think they're kind of busy, so they're not piping in. Actually, they might have left. They've left. But yeah, so I think what they've done is, so a lot of the information we've seen is talking about there's a fan out kind of topology, where you basically have the version of the operand in the CR, and then you try to measure that independently, and then that orchestrates the operand pieces of it. And then you've also got the one-to-one match, which is what the simplified approach, where you are mirroring the operator to the operand, right? So every time you upgrade the operator, you get the operand upgrade at the same time. We are largely not using that model. We're trying to use the fan out model because that gives us a lot more flexibility, even though it's more complicated, and that puts the orchestration on our shoulders. But that does give us that ability to do that orchestration and that multi-tenancy from that perspective.
That's fair. Is it important that the operator not be able, so from that perspective, right, like if you viewed the operator as a cluster extension that allows you to install a set of things, and you view your users as folks that you want to give, or let's say even service accounts that you want to give access to actually create that CR in their namespace, and that's how you're scoping whether it actually will create an operand for them there. How much the orchestration here, what is this orchestration that you're talking about, if not like having a cluster admin add a user want to use a specific API, right?
Yeah, I need to tease that out. Every Cloud Pak to us is a big application, right? It's a collection of operators, a collection of operands. And so, and all the Cloud Paks have to install, like they're not doing this today, but they need to install so they can all interoperate and so forth. So we're seeing this problem in spades. And so I don't have a really good answer there. They all kind of have their different perception of what operators are. And so I think we need to have some internal discussions to bring this up a level to make sure we understand what the end game is.
Yeah, like there's also like a world in which their application, right? And I know we talked briefly about this before, but the application that they're developing is their own thing that they're want to manage the upgrades with. Maybe it's super stateful. So it could behoove them to make an operator for that and also make a cube extension, right? So also you have a CR now. So it's very similar to the things that it may depend on, and that they're kind of rolling out their final state of a prod cluster is just making a set of CRs, or making a CR to their thing, like install their operator that pulls in all of their dependencies, but you know, I guess here's where you would bump into a scoping issue if different tenants had different requirements. Yeah.
It's always either scoping or API compatibility. You run into one of these at all times.
Yeah.
So I guess we need to decide what's more important. You know, different scopes, but same API, or different APIs and then same scope.
Well, I don't know. I'm just trying to like, how important is it for one tenant to not be able to install something that another tenant is providing, like as an application that they're managing? And if that's the case, can't it just be managed with RBAC, and does that need to be automated?
Yeah, I think this is what we need if we go the global route, right? You need some sort of setting where you define a list of namespaces or tenants that can use this operator, and then OLM magically does the RBAC.
Maybe. I don't know if, I think part of the problem, the reason we're into like predicting this now is because we've like historically done that. Yeah.
So we are going past time pretty pretty far, and I think there's a lot of good conversation here, and I really don't want to lose the momentum that we've got going. So could we create a vehicle to continue the conversation? Either have, I'm fine with setting up a separate meeting where we can go into this, or just bring it up in the OLM Dev working group, or we can make a GitHub issue and we can capture basically the information that we've at a high level like covered here. So and then maybe even revisiting that at the next OLM Dev meeting. I'm just trying to be conscious of people's time and also the importance of this topic.
Yeah, Evan is proposing a Slack thread. I think we should do that. We should probably try to distill some possible routes from which we can take from here.
Yeah, it'd be really helpful
list the pros
for
and
me.
cons of that.
It'd be really helpful for me, Daniel, if you could kind of put what you talked about in maybe a one picture or a couple of bullet points.
Yeah,
we could noodle
sure.
on. I typically I have to translate everything you do into a PowerPoint in my head anyway, and I get the blue screen of death half the time in that PowerPoint. So
and we should do the same with the global singleton model, right? Which seems to be, you know, kind of the elephant in the room that we're talking about.
Yeah, I think we need to be more. I think a lot of people are misunderstanding a lot of this stuff and through various channels. And so I think we just need to be very clear and transparent what's not possible, right? And how people might be misusing things and misunderstanding, especially customers, right? They have a completely, and for us to unwind that is really hard because they already made the investment.
Yeah. Okay. But still, thanks for your time and willingness to listen and coming in. This is super helpful.
Yeah, this is awesome. Thank you, guys.
Thanks, everyone.